Alright, here's a video going over the activities 8 and 9 review. You should go through here and see, keep track with check marks of what you feel confident in and what you don't. That way you can ask questions, come in and see me E and I, something like that. So a couple things to remember. Square root of -1 is I, and I squared is -1, because when you square square root, you're left with what's there. Okay, so, simplifying radicals, we've done a lot of this. You look for the biggest perfect square that goes into it nicely, and then imperfect squares, are these numbers, ... Write that at the top of your page. So when you find that number, it goes into 18, the nice thing about it is it turns into a 3. Not a radical 3, but a 3. The 2 doesn't turn into a nice one, but I know the square root of 9. So you should always do that. If you ever have a negative in there, it's just like a penalty. Like you can write this as I radical 32. And then simplify this guy as normal, because you can't take the square root of a negative, so it's imaginary. And then 16 goes into that. So we have an I out front, and 32 is 16 times 2. Square root of 16 is a nice number. It's more common to write 4i instead of I4. That's just weird. And then you can multiply them. Take number part times number part, and I times I is I squared. But remember, back up top, if you ever get an I squared, you can replace it with a -1. So it's really -20 times -1, which is 20. Okay. Similarly, when you're adding, you just add the number parts, and you add the I parts. -11i plus 1i is -10i. They don't really go together. It's standard practice in math to write the real number part first and the imaginary number part second. Foiling works the same way too. First times first. Outer, if you have -2 times a -4i, you get positive 8i. And then -4 times -2 is another 8i. And then last times last is positive 16i squared. So I can put these two together, and I'll get 4 plus 16i. What do I do here? Remember, that's a -1. So I can replace that with a -1. Instead of having plus 16, I get minus 16. And then these are like terms. I can take 4 minus 16, -12 plus 16i. You can check these on your graphing calculator. It is still standard practice to write the real number part first and the imaginary number part second. This thing, if you have a graphing calculator, which you should, this problem gets pretty easy to do. As long as you know, well, if you have a graphing calculator, you could just type that in, but otherwise, you have to know the cool way to do this problem, and that is to multiply top and bottom by the conjugate. Now the conjugate looks exactly like this, except that plus needs to turn into a minus. Okay, so when I multiply the bottom times the bottom, I'm foiling. First times first is 4. Outer is plus 8i. Inner is minus 8i. And last times last is -16i squared. It looks crazy, but remember, we're not allowed to leave an I in the bottom. That's why I'm doing any of this work. It's because it's illegal in math to leave an I in the bottom. But luckily, and I'm going to deal with the top later, I'll just FOIL that. But luckily, if you look at this carefully, you'll notice these two kill each other, because a positive 8i and a negative 8i kill each other. And then this turns into a -1, so the bottom becomes nothing more than 4 plus 16. It was 4 minus 16i squared, but that turns into a -1, so it cancels out the negative. So in the end, the bottom's just a 20. Okay, but the top, I'm going to FOIL. First times first is -2. Outer is minus 4i. Inner is -2i. And last times last is minus 4i squared. Once again, that turns into a -1. So this problem boils down to a -2 and then I can put those two together. Minus 4i minus 2i is minus 6i. And this was a minus 4i squared, but actually it'll simplify to be plus 4. Okay. And then I can simplify once more and put my number parts together and get 2 minus 6i. Now, this is almost done, except this is not the proper way to leave your answer. You want to split it into two parts. So we'll have 2 over 20 and minus 6i over 20. And then you do want to reduce your fractions. Like, don't leave it as 2 over 20, write as 1/10. And then instead of 6i over 20, it's 3i over 10. That's the final answer. Beautiful answer. All right. And then the 3 vocab words to describe solutions. Remember, we keep saying this. They're sometimes called zeros. They are sometimes called roots. And they are sometimes called x-intercepts. Hopefully you caught that the 9 million times we've said that. Maybe you forgot one, but... Alright, so what must you write in front of the number when you take the square root? A plus or a minus. Ooh, you got to remember that. Don't forget the plus or minus when you do the square root. So these two are good examples of square root problems. I know you're told to do that, but you should have noticed, see how there's no x term? And here there's no just plain x term? So my goal is to get that by itself. So you have to know your algebra 1, right? So 2x squared equals negative 81. Divide both sides by 2. X squared equals, that's 81 over 2. Ew. It's not going to be a nice answer. I'll just leave it like that for now. Okay. Now I need to square root both sides. Don't forget your plus or minus. Remember we just said that. So x equals plus or minus the square root of negative 81 over 2. Now that's pretty ugly, but it does get a little nicer when you do this and you're allowed to split a radical fraction up into top and bottom, because that on top is 9i. Because square root of 81 is 9, so square root of a negative 81 is 9i. Now we have one more thing to do, and that's because it's illegal to leave a radical on the bottom, so I need to fix that. And it's an easy fix. You multiply top and bottom by radical 2. So the end answer is plus or minus 9i radical 2 over 2. So when you multiply radical 2 times radical 2, it's 2. Alright, hopefully this next answer is a little nicer. Right? Add 42 to both sides. My goal is to get this guy by itself. Right? Divide by 6. Oops. X minus 2 quantity squared. And 42 divided by 6 is 7. And then I want to square root both sides. Don't forget your plus or minus. Because when you square root a squared, you get plus or minus radical 7. I'm almost to my answer. Add 2 to both sides, and it's 2 plus or minus radical 7. Nice answer. If those were both normal numbers, I would actually do it twice, once with a plus, once with a minus. These are square root problems. Basically, isolate the squared, square root both sides, don't forget your plus or minus, and simplify your answer. Okay, in order to do completing the square, your a must equal 1. And what formula do you use to figure out what to add to each side? It's b over 2 squared. Okay, you got to remember that part. Alright, so let's crank this out. I'll do one of them on screen and then one just to save some time. Okay, so once again, when you're doing this, kick that number out, because the whole point of completing the square is that you make room, and by kicking out I mean add 3. You make room for a special number here that's going to work. And that special number is found by doing this. b over 2 squared. So I'm going to take b over 2, so 4 over 2 and then square it. 4 over 2 is 2. 2 squared is 4. Whatever I add to one side, I have to add the other, otherwise it's out of balance. And then the whole point of that is, oh my gosh, I don't know why I did 4 squared, sorry. 8 over 2. 8 over 2 is 4, and 4 squared is 16. I thought that number seemed weird. Okay, whew. Almost a bad move. I already divided it by 2. I didn't need to do it twice. So I need to take 8 divided by 2, which is 4. And 4 squared is 16. That's how I decide my number that goes there. Whatever I add to one side, I add to the other. And the whole purpose of this is so I can write this as something squared. Now that something, it's the answer to the question, what multiplies to be 16 and adds to be 8, or you can just write the number before you squared it, right? When I did 8 over 2, I got a 4 before I squared it. So I could just write x plus 4 squared. And now we're like in these problems. I got my squared by itself, so I need to square root both sides. Don't forget your plus or minus. And then subtract 4. Negative 4 plus or minus radical 19. Awesome. Let me pause this, do the other one, take a look at it. Alright, so this next problem, if the beginning isn't equal to 1, you just divide everything by that number. So I divided this by 2, 2, 2. And then I have a nice number with a 1 in front. I kicked the 10 out. I found this special number by taking 2 over 2 and squaring it. And then I did the 2 over 2 here. I had to remember there's an I, because square root of negative 9 is 3i. Since the square root of 9 is I, don't forget your plus or minus. Awesome. Alright, this next section I don't think I need to go over. There's the quadratic formula. You can pause and look at all that beautiful work. It's just typing in A, B, and C. Just make sure, like I did here, you get it equal to 0 first. And then you do your quadratic formula. And I do expect you, if they're nice answers, to actually do it once with a plus and once with a minus and get your 2 answers. Then we have discriminant. This is just like our notes. That's the b squared minus 4ac. And you get those solutions. So if I did this problem down here and saw it as a positive 32, that's not a perfect square, so I get 2 real, ugly, or irrational solutions. Alright, number 4, I'm just trying to see if you know what it looks like to have real solutions or imaginary solutions. So if I graph this one, and it says sketch, so we're not looking for anything crazy good. If it never hits the x-axis, I have no real solutions, but I have 2 imaginary solutions. And then we look at this graph, and if it does that, alright, I got a sketch, something like this. It has 2 places it hits the x-axis, so there are 2 real solutions. The only case not shown here is what happens if it just barely strikes. That would be the one real solution where it hits just once. Okay, that wasn't one of these problems though. Alright, so the last page here, you always check if you can do square roots first, because it's super easy. Then if you can't do square roots, if there is an x term, you try factoring. Not all problems are factorable. If not, you use one of these 2 methods. If the middle term, the x term, is odd, I would definitely go this way. If the middle term's even, maybe this way, as long as the x has nothing in front of it. These 2 guys are the best because they always work. Alright, so these are my favorite here. Algebraic method means I can't use graphing. Show my work. So here's my thought process. When I look at this one, I see a middle term, so square roots won't work. I check for factoring. Can I think of 2 numbers that multiply to make negative 6 and add to be 5? Yes, I can, so I'll do that. Let me pause here. So I chose factoring because I can't do square roots due to that 5x there, being a middle term. I could think of numbers that multiply to negative 6 but add to be 5, and when I do, I get my 2 answers of negative 6 and positive 1. Easy. Alright, so this last problem, I would use quadratic formula because as soon as I see that thing there is not a 1, shoot, I don't want to do any other method. So I just write down my ABC, I'm really careful, and then I finish the problem up. And there's the rest of the problem. You get imaginary, you can simplify the radical, and then divide it into 2 chunks, and you get your cool answer there. Alright, hopefully that did well. Good luck, study hard.